Hi, I'm Tyler.
And I'm Justin, and today we want to talk about how Earth Engine apps can be used to showcase and provide interactive exploration for geospatial datasets that have been presented in research publications.
That's right. It is common for earth science researchers working with geospatial data to write up their work as a manuscript and then submit it to a journal for peer review and publication. For earth scientists, publishing is an important part of the advancement and evaluation process, and many live with the pressures of publish or perish. Now, while publications can be a great way to summarize the major findings of your research, they also have some pretty significant limitations in terms of providing broad access to the research results. If all a reader had was a hard copy or digital copy of the manuscript, it would be a significant amount of work for them to access and explore the end results, even if that data was posted in a data repository where they could download it. Earth Engine apps can be used to facilitate access to large data sets described in a paper, and they can be set up to be accessible by anyone with a web browser. An Earth Engine app can be made to make your research more discoverable. An app can contain links to resources such as the published manuscript, the research group's web page, or to a data repository where viewers can download the resulting data, or even the source code used for the analysis. Earth Engine apps can be a great way to participate in open science. You can allow others to easily replicate and build upon your published research.
I have a good example of feeling limited by traditional publications. In 2012, before Earth Engine and web map hosting became popular, I was part of a project that mapped forest disturbance in western Washington, Oregon, and Northern California. And because the area is so large, the paper we wrote could only show and describe broad spatial temporal patterns of forest disturbance, which was a little disappointing because there were so many fascinating local scale patterns and events that came to light. The best we could do was a single inset. And there's just not a lot of value in printed maps of large regions for local scale interpretation. We did provide the data, geotiffs and shape files for download from an FTP server for people to explore on their own, but we realized that this was severely limited. It limited the access to only those with technical skills and the time to work with the data. And this always felt unsatisfactory.
The need to provide access to large data products is becoming more and more common as advances in cloud computing make it easier to conduct regional to global scale analyses involving terabytes to petabytes of data. Earth Engine apps are already being used for this, and here are a few examples. The first example I want to show you is the Global Forest Change Viewer. This app allows viewers to explore deforestation and reforestation around the world. The next app I want to show is the Global Population Explorer. This app allows viewers to explore population statistics datasets produced by the European Commission's Joint Research Center, Global Human Settlement Layer. And here is the Global Safety Net Viewer. It's an app that allows exploration of terrestrial areas essential for biodiversity and climate resilience. And finally, here's an app for the U.S. Urban Tree Cover Inequality Atlas. Here's an app that explores the relationships of tree canopy, temperature, and socioeconomic data. And Justin, didn't you make an app to help visualize the temporal component of the Global Surface Water dataset?
That's right. So check it out. Here we have the JRC Global Surface Water dataset, and we're looking at the Ucayali River in Peru. And I can draw a region around it, and we can get a time series animation of fading river history. So wait for it. It's generating it. And there you have it. Pretty cool, huh?
Okay, so hopefully we convince you that Earth Engine apps can be helpful for sharing your research results with a broader audience and aid in increasing its impact. Let's talk about how to go about building an app to accompany your research paper. So what are we going to cover in this video? Well, we'll start off with a high-level description of Earth Engine user interface widgets and Earth Engine apps. We'll then go over a suggested way of organizing your code in order to make it easier to maintain over time. Next, we'll do a detailed walkthrough of the steps of creating an app, including how do you get started, what process will you use when you're adding a new feature to your app. And finally, we'll provide some links of where you can go to find additional information. Justin, would you like to start us off?
Sure. Let's get started with the basic components of an app, the widgets. So widgets are for app design and function. I'm at the code editor here, and you can see that I'm on the docs panel and I'm looking at the UI module. So everything under the UI module are widgets, and they can be used in your app to show data and to allow users to interact with your app. In the code editor script panel is where you develop your app, and the bottom panel is the app canvas. So this is where you'll be seeing your widgets appear, and you can be interacting with them as you develop your script. So what I have here right now is just a smorgasbord of the widgets that are available, and I'll just quickly walk through them. We have a button, a drop-down selector, checkbox, a slider, a date picker. We have a Slippy map. We can include thumbnail images. We have a panel that can hold other widgets. This one's holding a label. We have a slider panel. We can include input, and we have interactive charts. And it's also worth noting that any script that you have developed to analyze data can be run in your Earth Engine app. So your Earth Engine app is live and can be making Earth Engine requests on the fly. For instance, I've hooked up this little app to show a hillshade layer when I click this button. So now you can see that this Slippy map, there's an overlay of a hillshade layer. So that has happened on the fly. A DEM has been multiplied by 50, and then hillshade has been calculated and overlaid. So anyone can access your Earth Engine app. And this is really important for sharing your research widely. So as a developer, you need to have an Earth Engine account. And when you publish your app, it will be hosted under earthengine.app with your own subdomain that's tied to your account. But you can share your app with anyone, and they don't need to have an Earth Engine account to be able to explore your data. So let's do this. Let's build an app, start to finish, to show you the thought process and provide some practical tips for building apps.
Okay, so let's talk about the dataset that we're going to use to demonstrate the process of building an app. The name of the paper is Improving Landsat Predictions of Rangeland Fractional Cover with Multitask Learning and Uncertainty, and it was published earlier this year in the Journal of Methods in Ecology and Evolution. As part of the research described in this paper, a new spatiotemporal dataset was created. A short summary of the dataset is, a convolutional neural net was trained to produce a fractional land cover product for rangelands in the western United States. The dataset covers 37 years from 1994 to 2020. It's at Landsat scale, 30 meter pixel size, and it considered 6 fractional cover classes. For each class, there's both a best estimate of the coverage and a corresponding measure of uncertainty. The fractional cover estimates are presented in the paper, and they dedicated a full page to the presentation. But because the research covers such a large spatial extent, the map scales correspond to about 800 miles per inch of paper, if you like to use the imperial system, like in the United States, where the research is based on, or 500 kilometers per centimeter of paper, if you like to think in metric, or 1,300 kilometers per inch if you're Canadian.
Wait, what? Did you say kilometers per inch?
Well, Canadians measure the distance in kilometers, but their paper sizes are in inches, so I thought the conversion might be helpful.
Okay, I see.
Anyway, this is the dataset that we're going to use while describing how to build an Earth Engine app. Full disclosure, we don't really need to build a web application to explore this data, because anyone can already explore this data using the Rangelands Analysis Platform, a custom web application.
Hey, did you select that paper just because you're a co-author?
Well, that might have been a factor, but I also think it makes a pretty good case study. The research produced a very large spatial temporal dataset, and we want to demonstrate how to build an Earth Engine app that makes it easier for people to explore and interact with the data.
I think it's a great example. So let's talk about the components and functionality needed to explore this data in an Earth Engine app. I think we can represent this data well with two components, a map and a time series chart. We can have the user select a year and a cover type to view in the map, which will allow them to interpret spatial patterns. And we can let them click a point in the map to get a time series chart of cover composition for a region around the clicked point. And to guide their initial exploration and introduce them to the app, we could include a few example locations. I'm thinking that we have a drop-down menu with these locations, and if they click one, the map will zoom to that location and a time series chart will display. And we can include a small blurb about the data story that we see there. I'm also thinking that we should include URL parameters in this app to preserve the state when we share a URL with colleagues. So I want them to be able to see what I see when I share a script. So if we use URL parameters, we can do that. Okay, I like the track that we're on with this functionality. Let's talk about its layout. So how about this? I'm thinking a control panel on the left, part of the screen, and a map on the right. In the control panel, we'll include info like the title, a description, a link to the paper, and any other kind of relevant resources. And following the info section, let's include a slider that allows a user to select a year to display, and below that, a drop-down menu that allows them to select the cover type, the band to display. And after that, we'll include a slider widget that allows a user to select the radius around the point that is selected on the map, which will render the chart. And the final component, I think, should be these guided tours, a set of examples that will have the users select from. And this could be, like I mentioned before, a drop-down widget. So moving on to the map, we could have a legend in the lower left corner and the map in the lower right corner. I'm thinking this is going to be a pretty good app. What do you think, Tyler? Yeah, nice. I think that's exactly what I'm going for. You know, I think that you and me might have a future in web design. Okay, so now that we have our app all sketched out and our target is fairly complicated, I think we need to come up with a good way to organize our code. Now, Tyler, I know that you've thought a lot about this topic. I'm wondering if you'd share some of your thoughts on structuring Earth Engine app code.
Well, the minimum amount of code needed to create an Earth Engine app that displays a dataset is just one line. To create a truly useful app, you will often be including much more than that. Code that allows a user to add interface controls, change the default styling, or filter and manipulate data. And all that code can add up. Apps can grow to be hundreds of lines long of code, and it can be difficult to keep all of that in your head. So it's a good practice to write your code using a specific software design pattern, commonly known as a framework. Using a framework separates your code into distinct sections based on the purpose of the code. Even though you may not need this level of organization for just a few lines of code, we encourage you to start using a framework from the beginning, before your code gets complex. Using a framework can make it easier for others to understand your code, whether it's a collaborator working directly on the code with you, or someone else in the Earth Engine community that's trying to help you with an issue. And often, that other person that you may be helping by making your code more understandable may be yourself a week or a month out into the future. So what framework should you use? Well, there are lots of frameworks for web applications that have been proposed, used, argued over. You may have heard of MVC, or the Model View Controller framework, which is one of the most popular. But there's also the MVP, Model View Presenter, the Hierarchical Model View Controller, the State Action Model, or the Model View View Model. And we're not going to suggest that to use any of these specific frameworks, but the fact that they exist reinforces the idea that organizing your code is very important. But if you're not already using a framework, we're going to suggest that you use the following section template, inspired by the ideas behind MVC and the other frameworks. So this template that we have includes a model section, in which you will define important information about the data that's being presented by your app. A components section, in which you will use to define user interface widgets and collections of widgets that your app will use. A composition section, which is used to arrange the components into a full user interface. A styling section, which defines and set widget style properties. This is where you can change your app from just being functional to functional and looking good. A behavior section, which defines how the app behaves when the user interacts with a widget. And finally, an initialization section, which, handles initialization of the app. Okay, so now that we have a framework for organizing our code, Can we just start writing some code now? What do you think, Justin?
That sounds good, Tyler. I think the first place that we should start is by looking at this framework in a code editor script. So if you look at my screen, what we see here is an empty framework template, and it includes all of the sections that Tyler just mentioned. And you can find a link to this template in the event description. So I'm going to walk through it. We've got our model section, and if you recall, that is where we define information about the data being presented in our app. We have a components section, and this is a section where we'll define all of the widgets that compose the app. And then we have the composition section, which is where we arrange our app. We add widgets to panels and to the map. We also have a styling section, and this is where we define styling properties for our widgets. If we want to make text bold or change the font size or background colors of panels, this is where we do it. We also have a behaviors section, and this is where we define app behavior on UI activity. So for instance, when a user clicks a button or moves a slider, this section is where we define functions that will fire on those events to handle what the behavior, what we are expecting the app to do. And finally, we have an initialization section, and this is where we initialize the app on state load. It might be where we are defining initial values for some of our widgets. And if you notice, some of these sections have empty objects. This is the case for the model, the components, and for style. And these are here as a reminder and as a prompt for you to add variables to these objects. Think of them as containers to organize your information in these particular sections. And this framework is just a tool. There are no hard rules here. We've given some guidelines in each of these sections for what you should do with them. But mostly it's just a tool for us to help organize our thoughts and structure our code. So let's look at this in a small example before going on to building our script. I've got an app here that I've built that's very simple. It is 2 widgets. I have a drop-down selector, and there are 2 years in there that we could select from. And what I want this app to do is when I select a year, I want it to update this label widget. And so if I do so, you can see that when I select a year, the label updates. So let's just walk through again in this framework and see what these things look like. So the data that's in this app is a list of years. I've got 2020 and 2021. So I'm in my model section, and I have added this years list to my model object. And then we have our components section. And remember, we have 2 components. We have a year label and a year selector. And I'm adding both of these widgets to my components object. And in this case, the label, I'm leaving it blank because I'm going to initialize that at the end. And the list of options for my drop-down are coming from my data model. They're coming from the years list. And I've just included a placeholder that says select a year. It prompts the user to do something on that drop-down. And then we have the composition section. And the first thing that we're doing here is we're clearing the root. The root, you can think of it as the app's canvas. When you load an Earth Engine code editor session, you see the default map. That is a map that's on top of the root. And what we want to do is clear that map out, start fresh, so we can add our own widgets to it. And so what we do here is we clear the root, and then to the root we add our year label, and we add our year selector. And moving on to styling, you can see that I have made the background of the year label orange. So I've made this style property set for the year label, and I also have style properties for the year selector. I've increased the width of the drop-down selector a little bit. And to apply these, each widget has a style method which returns a set of properties. It's an active list, and active lists are mutable, which means that we can set them. And so what we're doing here is we're getting the style for the year label, and we are setting the style properties according to what we've just defined in these year label style properties, these custom properties. And we're doing the same thing for the year selector. And now if we were to run this, we would see that both of our widgets are added and that they have the styling that we want. But if we were to select a year, we would see that nothing would happen with the year label. It wouldn't update. So we need a behavior. So we're into the behavior section now, and I have a function here called update label. And what it's doing is it's being registered to this onChange event. So our year selector, the dropdown, it has a listener, and it's called onChange, and it's listening for an onChange event. So when you select something, it knows that something has been selected, and you can register a callback to that event. And so that's what we've done here. We have this update label function, which when fired, it gets the value from our year selector, and we've saved that as a variable. And then it sets that value to our year label. And then lastly, we have the initialization section. And as I mentioned above, our year label was null to begin with. And so at the end here, because this is a dynamic widget, it's going to be updated on a change event. I wanted to set it under initialization and not hard code it above. And so by default, I'm giving it just a year, and I don't know what that year is, so I'm just leaving some question marks. And then when somebody selects it, it will update. So I hope that going through this framework template a couple times has brought you some familiarity with it. And next up, we will move to an empty template again and start building our sketched out app from scratch. So let's go back to the empty template and get started. So if you remember back to the sketch, the main components of our app are a control panel and a map. So let's start there. Since those are components, I'm going to head down to the components section and add them in. And what I'll be doing is copying over code I've completed previously in small chunks, and I'll describe them as I go. So here we have a control panel widget and a map widget, and I've added them to my components object. So I have an empty panel and a default map. And if I were to run this right now, nothing would happen. They've not been added to the root or to any widget that exists here. And what we're seeing right now is the default UI map widget. And the first thing we want to do is get rid of that, so we have an empty canvas to work with. So what I'm going to do is clear the root, and that's in the composition, how my app looks. So if I run it, you can see that there is no default map anymore. I have a clear, clean root to work with. And on top of that, I'll add our control panel and map. So here we have our root, and I am adding the control panel, and I am adding the map. So if I run this, we should see we have a map, but where is our control panel? We can't see the control panel right now because there are no widgets in it to give it any width. So we can fix that by adding some style. So I'm moving down to the style section of our template, and I'm going to copy over some style to add width to the control panel. And this type of styling is what we'll call inline styling. So you might have style classes, and you might have inline styling. And inline styling is applied when there is a single widget getting this style application. So we only have one control panel, so we're just going to set it in place. And each widget has a set of styles associated with it, and you can access those using .style, and that returns an active list. And active lists are mutable. You can change the properties in it. And so we can set our style properties according to whatever we like. In this case, we are updating the width parameter to 275 pixels. And so if I run this, sure enough, there we go. We can see our control panel now, and we can see our map. So next on our sketch was a title and a description. So let's add those in. Those are components, so we're headed back up to the component section. And I'll copy in the info panel. Okay, and notice here that I'm first adding an empty object called info. So we want to continue being good about organizing our code. So we already have our code broken up into these sections. And then within these sections, we want to continue grouping and organizing our code. So one way to do that is to include widgets that belong together that wouldn't make sense if they were out of order, for instance. We want to define them inside of like containers so that they're with their kind of partners. So we have this section that's going to contain multiple widgets that are about info. So we make this empty info container, and the first thing we'll add to it is the title label. So I've got a UI label here, and I'm going to title my app Rangeland Fractional Cover. And we also have a description that we want to add. So I'll copy that in. And similarly, I'm adding this about label to my info object, which is a child of my components object. So I've got a nice description here that tells folks what my app is about and maybe some of the things that it does. And now let's check these out. We can do this a couple ways. We can preview it in the console, which is a nice way to isolate your app from any other widgets. And we can also just add it to the app we've started to develop here. We could add it to the control panel. But let me demonstrate printing widgets to the console. So I can just print this title, and it shows up over here in the console. Or I could print the about label, and it shows up in the console. Now, since these are two things that are part of a group, sort of our information, we've already included them together being defined in this info object, but we also want them to be grouped together in the representation of our app. And so to do that, I want to wrap these two widgets inside of a panel. So I'm going to add that in. So I've got a panel, and I'm just wrapping the two widgets inside of a list, and I can preview this. And I see now that I have my label and the description, and I'm happy with that. So now I'm going to add it to my control panel in the app. And that is down in composition. We're changing the view of our app, what it looks like. So I have my control panel, and I am adding to it the info panel. So if I run this, we can see that it's now added to the control panel, this information. And it's worth pointing out that you can't have widgets in multiple places. So if I were to try to print this panel to the console and also add it to my app, to the root, it won't let me do that. So I'll just demonstrate that. So it's telling me widgets cannot be added to the panel if they have been printed in the console. Just a word of caution. All right, this is looking good. Now, the next thing on our list was the ability for a user to select a year. So the data set that we're working with is a time series of rangeland fractional cover, and an annual time series from 1984 to 2020. So we want a user to be able to select any year in that range to visualize, to render to our map. And we're going to do that with a slider, and that's a component. So we're headed back up to the components section. And I'll copy in our year slider. So as I did with the info section, I am defining an empty object, and I'm adding it to my my components object, as it's called select year. And to select year, I'm adding a label and a slider. So for anything where I'm having a user select something, I want to give them a prompt, and so I add a label, and I'm calling it, in this case, select a year to display. And then below it will show up the slider. And the slider needs some parameters. It needs a min and max value to slide between and the step. And what I like to do is define these just sort of arbitrarily as I'm testing this. I'm making a note to myself that eventually I need to get this information from my data model. This is going to be the start and the end year of my image collection. But just for the sake of testing and getting this running, I just hard code some arbitrary values. And again, since these components belong together, I'm going to wrap them in a panel, and then we'll add this to our app in the composition section. So we have our control panel, and we are adding to it the select year panel. And if I run this, we should be able to see it show up. Sure enough, we've got a slider with values 0 to 10, and they went at an increment of 1. So that's great. And then next on our list in the sketch, we had a drop-down menu for users to select a band, and the bands represent cover type. So let's add that in next, and that's a component. So we're going back up to the component section. Hopefully you're recognizing a pattern here, kind of between the components and the composition, going back and forth and iterating, adding as we go, testing out. Okay, so again, I'm adding this empty object to my components object called select band to keep this section of objects or of widgets organized. And I have, again, a label. I'm prompting the user to do something. I want them to select a band to display. And then I have a drop-down selector, and I'm just initializing it with an empty list. Again, this is just me wanting to get everything sort of set up and looking okay on the app. And I'm making a note to myself that I needed to get this information from my data model. And since these two bits belong together, the widget label and the selector, I'm wrapping them in a panel, and I can add this panel to the app. And if I run it, we should hopefully see a drop down. There we go. So now we have a drop down, and there are no values because I provided an empty list. So we have two widgets now that are there, and they are depending on knowing something about our data. So let's work on the model at this point. So we're going all the way back up to the top, and the model is where we will define information about the data to present in our app. And I'll copy over a chunk of code here. Okay, so the first thing that you see here is that I'm importing the image collection, and I'm adding it as a variable to my model object. And I'm also adding an object called image info, and that's going to store all of the information about my image collection, the start year, the end year, and information about the bands. And the bands are important here because we want users to select them. So we need to know about band names, and we also want to have a chart where we show a stacked bar graph of fractional cover, and so we want to be able to display a unique color per band, per cover type. So so for each band, I include this same bit of information: a human readable band name, the band name as it appears in the image collection, a color to be assigned to it in the chart, and then visualization parameters for how to display it on the map. And there are many ways that you could develop your data model. This just happened to suit the purpose here for this app. The point being that we just want to continue within each of these sections, keeping our data organized and kind of modular. So now that we have some information about our data, we can fill in our two widgets. We know the start and the end year for our slider, and we know the band names for our drop-down band selector. So I'm going back down to the components section to fill those in based on our data model. So now I'm getting the start and the end year from my image info object in my model object. And then we have our band selector. And since I've arranged the data model to have band names as keys, I can easily generate a list for them. And we also need to initialize this with a null value. So we'll just have the placeholder be null and have the value start as the tree band. So now that we have our selectors updated with the proper information, we should be able to run the script and see that it is reflected in our app. And it sure enough is. We have 1984 as the min year for our slider and 2020 as the max year. And we have initialized tree as the band to start with. And we can see that we have all 6 cover types available for us to choose from in our drop-down menu. So this is great. We're getting close. We can select year and band, but they're not hooked up to a behavior yet. So when we select them, nothing is happening. What we'd like to have happen is for a map to render when we've made a selection on either of these widgets. And so that's a behavior. So let's head down to the behavior section. And I'm going to bring in a function that will render a map when either the year selector or the band selector has changed. So what we have here is a function called update map. And there are 2 important pieces of information that this function needs. It needs to know the year and the band for the data we want represented. And from that information, it can filter the image collection down to a single image that represents, the selected year and band. And with that image, we can build a map layer. Now, what I've done here is to hard code the year and the band. Eventually, we want this to be hooked up to on-the-fly fetch this information from the widgets. But for the sake of testing and sort of isolating potential problems, I'm going to hard code this just so we can test. So at this point, our function assumes that the year is 2000, the band is shrub, so it can get the image that represents those criteria, and it can build a map layer. And we know how to visualize it because of the way that we've structured our model, our data model. Since we know what the band is, we can retrieve its visualization properties, and we can assign a name to this layer because we know the band and the year. And then finally, we have this map layer, and we can add it to the map using a set of functions here where we are calling on our map to fetch all of its layers. And this returns us an active list, and active lists are mutable, so we can set things about elements in the active list. And so what we want to do is set the 0th layer to the layer that we've just created, that is our image based on the selected band and year. And to test this, we can run the function in the initialization section. And because we've hard-coded values, we should see a map rendered even without selecting anything from the UI widgets. And so sure enough, we've got data on the map. It's showing us 1984 tree cover. And we should, if we were to slide and change to 2020, for instance, we can tell that nothing is happening. And we can do the same for selecting a band, and we can see that nothing is happening. We just know that our function can render a map. So what we need to do next is register our function with listeners. So our two widgets, our slider and our selector, they both have listeners, and we can they're called onChange in this case is the event name. And so they have a way for us to register our function to the listener so that when a change occurs, our update map function will fire. So here I've done that. We have our slider and our selector, and we are calling on their onChange event, and we are adding to it the update map function. So if either of these, either the slider or the selector change, our map should be updated. And if we run this right now, we'll see that they still won't change, and hopefully you'll get a clue why. So our function is running each time. So now this is different than last time. Last time there was no change at all. This time our map is re-rendering, but the data is not changing. So we know that our callback is working because we can get it to re-render on change of the slider and the selector. But because we have hard-coded our year and our band, nothing about the map is changing when it's being re-rendered. So it can be helpful to set these, but you also have to remember to update them to fetch information on the fly. So now what we're doing is we are getting the current value of the slider and the selector when the update map function is called on an onChange event of the slider and of the selector. So hopefully when we run this now, we'll have everything hooked up. Okay, so this is already looking positive. The color is different in the map, so I know that we are using a different, it is using a different band, which is the tree band. And if we choose a new year, we can see that the map looks different. And if we choose a different band, we can see that the color palette is different. So now we know that it is fetching whatever the current state of these widgets are when the update map function fires. All right, so this is pretty good. We've got an app that is pretty useful on its own, but in my opinion, it doesn't look great at this point. I would like to make the title bold and a little bit larger font. Make the information a little bit smaller font, perhaps. Bold the title for the widgets, and make these two selector widgets span the width of the panel. And also, it might be nice to add in some dividers between these bits of information and selectors. So let's do that real quick. The first thing I'm going to do is add in the dividers. So these are components. So I'll go back up to the component section. And hopefully you're recognizing this pattern. Again and again, we are adding an empty object to our components object called dividers. It's a container for all the dividers that we'll have. And remember that we can't have any given widget added multiple times. And so even though we have dividers and they all are going to look the same, they need to be separate individual widgets. So we're just repeating a couple panels. And we need to add these to the control panel in the composition section. So we're going down to composition, and I'll insert the dividers between the information and the selectors. And if I run it, we see no change, and that is because empty panels, right, they don't really have a width or a height. There's nothing in them to give them any kind of width or height. So we need to take care of that in styling, and we can also then take care of the other things that we had mentioned about wanting to improve with regard to styling. So the first thing I'll style is the title, the app title. And this, like our control panel, is an inline style. There's only one title, so my style properties will only be applied once in this case. So I'm calling style on my title label to get the active list of styles, and then I can set those style properties according to what I like. So I'm going to increase the font size and make it bold font. So if I run this, we can see that we now have a bold font, larger title. And then I'm going to add some style classes. So what I've done here is I've added style classes for the about text. So this affects the description text. But if you remember in our sketch of the app, we also wanted to include a link to the manuscript and also to the lab's website. And so for those three types of text, I want to have the same style applied to them. So I make a style class and I add it to the style object. And the same goes for my widget titles. So we have these prompts for like select a year to display and select a band to display. I want to make those a little bit bold and change some other things about them, and I want to apply it multiple times. And so I make a style class for that, and I'm going to make a style class for stretching my selector widgets to the full width of the control panel. And I also have a style class for the dividers. So I've defined these style classes, but they've not been applied to the widgets yet. So we still need to do that. So now if I run it, we can see that we've got a nice looking app with a great control panel now. Yeah, and in its own right, we could be happy with this app the way it is, and it would be much easier to explore the data set using this app than looking at it on a manuscript's results or discussion section, figure. But we're still a long ways from the sketch that we had in mind. And I don't want to go through all of those bits the way that we have been. So what I want to do is take a pause, a little intermission, and I'll come back and there'll be a bunch of code added, and I'll describe some important parts of it and show you the new pieces of the app. And I'll do that a couple times. Yeah, and I just want to make the point that this is a fluid process, and I hope that you've recognized that we are doing a lot of iteration, that we are bouncing back and forth between these sections of our framework, and we are testing out every piece that we've added. And we will continue to do that to the end of this app. So wish me luck, and I'll see you in a few minutes. Welcome back. Since I saw you last, I've added about 70 lines of code to include a legend. So we want this legend here so that viewers can associate color with a value of fractional cover for the different classes that we have in our data set. And so those 70 lines of code, a large majority of them are defining the widgets and styling those widgets. So there are 7 widgets that compose the legend. There are a lot of UI labels. There's one for the title and one for each of the values you see under the color scale bar. The color scale bar is a UI.thumbnail widget, and it is being represented by longitude. So we've applied this color gradient to longitude, and we're wrapping all of these elements in a panel that we've added as a transparent background. And the other part of the code is a behavior. So we need this to be dynamic. When a user selects a new cover class, the color palette changes. So we needed to include a behavior, a callback function that gets registered to the onChange listener of our band selector. And what that function does is it queries the current value of the band selector. In this case, it's shrub, and it goes to our data model and fetches the visualization information for the shrub band, and then regenerates the color gradient UI thumbnail and re-renders it there. So this looks really great. I'm happy with this. And next up, based on our sketch of the app, I want to add a chart so that when a user clicks a point, they will see a time series of cover classes. So yeah, I'll see you in a few minutes. Hello again. So I've added about 120 lines to include a chart, and you can't see it yet, but the event listener and the callback are ready and waiting for me to click a point. So what I'm going to do is demonstrate it by showing you a region around Mount St. Helens. And if you're not familiar with Mount St. Helens, it's a volcano in Washington state, and it erupted in 1980. And to the north of it, the blast knocked out a huge region of trees and vegetation, and this region has been experiencing a recovery since then. So this is a good place to show a story in a time series chart. So I'm going to zoom into a region, click a point, and you can see that a chart is rendering. The chart is large right now because I'm zoomed into my browser so you can see the code better. But here we have it, the chart. It's a relative stacked bar chart where each year is a year in our image collection, and each bar segment is a cover class. And so what we can see happening here is if you look at this dark green color, these bar segments represent tree cover. And our time series starts in 1984. So at that point, there is very little tree cover. Most of this is bare ground and litter. And over time, we can see that the tree cover fraction is increasing. So this is a cool story of recovery in a chart. And this is something neat that you can't really do very well in a peer review publication, at least not being able to let people explore wherever they want within the extent of your data. And what we've done here is added also a slider so that a person can select the radius of pixels to summarize under the region. So in this initial selection, it was a 30-meter radius, and I have now selected 300. So if I click again, you should see that the region now is larger, but we still have the same time series signal, maybe just a little bit more smoothed out. And I've also added functionality to hide the chart and to show the chart. So depending on what a person is interpreting, if they're more interested in spatial patterns, they can hide the chart. If they're more interested in the temporal patterns, they can bring the chart up again. So this is really great. At this point, we have a chart, an app that is super helpful, and we'll be happy to share it with colleagues and the public. But I think in our sketch, we have one more feature that is a set of examples, kind of a guided tour for users. If they're visiting our app for the first time and want to be introduced and sort of get an understanding about what is in the data and how to interpret it, we want to provide a guide. So in this next segment, I will show you a few examples. And so I'll see you in a few minutes. Great success. I've added an example locations widget section here. So let me show you what it does. We have a drop-down selector that prompts the user to select a location. And under it, we've added 3 examples. We have woody encroachment, invasive annual grasses, and wildfire. And if we select one, I'll do woody encroachment. A few things will happen. The first thing that you can see is that the map has zoomed in to a given region and drawn a circle over a region, and it has plotted a chart for that region. We can also see that there's a short description accompanying this example. It says woody encroachment in Great Plains grasslands, Nebraska. So just a little guide, a little bit of context for the user. And this is really neat. So we can identify stories in our data and show users what to key in on. And in this example with woody encroachment, the chart's pretty interesting. We can see that in 1984, the majority of this region's cover is dominated by perennial forb and grass. And as we go through time, we can see that that fraction gets quite low and tree cover has been increasing. We could also take a look spatially and look through time. So right now it's 2019. I could go back to 1988. And we're looking at tree cover, so you can see now it is much less. I'll go back to 2019. So this is really cool. Just a nice little guide for users and getting them started with your app. And what we've done here is added some data to our model. So we have information about our locations. So we're in the data model, and I've added 3 different locations: woody encroachment, invasive annual grasses, and wildfire. And for each, I have the longitude and latitude and the zoom that I want to have it displayed as in the map when a user selects one of these examples, and then a short description. And the callback function for the event listener, when somebody selects an example, it is updating the description, and and it is zooming into the location, drawing the region, and then generating a map for that region. So this is quite complete. I think the last thing that we had on our list is URL parameters, and that provides the ability to save the state of your app. Whatever you're seeing right now can be saved in parameters in the URL, so that when you copy and share that URL, whoever opens it will see exactly what you are seeing when you save or when you copy the URL. So I promise this is the last time I'll be taking a short break here. So I'll see you in a few minutes. Have you all seen that animated meme of a cat frantically pawing a keyboard? That's what's happening during these intermissions. So I've added the URL parameters, and I've also added links to the paper for this data set and to other related resources. And nothing about the app has really changed when you add URL parameters. But if I go up to the URL, and hopefully you can see it, it may be small, but you can see that there are now parameters and values included. So I have longitude, I'm seeing zoom, band, year, radius, and these parameters are associated with the state of the app. So whatever our year selector is, it's being recorded in the URL. The band to display is in the URL. The location, the example location that a user may have clicked on, the extent of the map, and so forth. And this is all happening in between the initialization and the behavior section of our code. So I'm looking at the code now, and I'm in the initialize section. And previously, we just had update map and update legend to initialize what was shown on the map panel. But now we have added a bunch of lines of code to set the initial values for all of our interactive widgets. So for instance, I'm looking at the year slider. This is where we're selecting a year to visualize. And you can see that I'm setting the value of it based on getting a URL parameter that we've called year. And by default, if the parameter does not exist in the URL, it defaults to the year 2000. So we're doing this, we're setting all of our interactive widgets based on URL parameters. And so that's great. That initializes the state of our app either by defaults or through whatever's in the URL parameters. But we also need a way to update these URL parameters. So anytime we make a change to one of the interactive widgets, that change will be recorded in the URL. So I'm moving up to the behaviors section. And for example, we can look at this update URL parameter for the chart. So we want to track the location where the chart is describing a point that's been clicked. And so we need to know the latitude and longitude for that point that has been clicked so we can re-render the chart. And so we write a callback function that is setting the URL variables for the chart latitude, the chart longitude, and in this case it's getting them from a parameter that had been saved when you click the chart, or when you click a point to render a chart. And then we are adding this callback function. We are registering it with the onClick listener for the map, so that anytime a person clicks on the map to render a chart, it's also going to be updating the URL parameters so that the lat and lon for the chart region are included. So this can take a little bit of time to include, but I think it's a really nice way for you to be able to share your app and show people exactly what you're seeing and have a discussion without having to describe in an email, what your settings were. So what do you think, Tyler? Pretty good, eh? I think it matches really well the SketchUp. And so what's next? I imagine publishing and sharing?
Okay, now we have a script that displays a user interface in the code editor. We can share it with anyone else who has access to both the code editor and to the data that the script refers to. But what if we want to make it even easier to access by anyone? And what if we wanted to hide the code because most of the users won't really need access to it? Well, you guessed it, Earth Engine apps to the rescue. So let's go through the steps of creating an Earth Engine app. So I'm going to start with the code editor in which we can see our script here. And I'm going to go up and click on the apps button. This opens up a dialog that we can use for managing apps and creating new ones. I'm going to click on the New App button, and we'll select the account that we want to use to create the app, give it a name. For example, this is going to be the example EE app for a research paper. Then we're going to associate this app with a cloud project, and if we don't have one, we can create a cloud project to associate the app with. After we've done that, we're going to click the Publish button. Then we'll have to sit back and wait for a few minutes. It takes a little bit of time for the app to be set up behind the scenes and be accessible to anyone. So we're just going to wait and check back in. All right, we've waited a few minutes, and now we can click on the app name, the URL here, to launch the app. You can take the app URL and basically share it with anyone. So in this video, we demonstrated how to create an Earth Engine app to accompany your research paper, and we walked through some of the key steps. Of course, this video couldn't describe everything that you need to know, so here are a few resources that you might find helpful. EarthEngine.app will take you to a selection of example apps, which may give you some additional inspiration for features that you can add to your own app. There's the Earth Engine docs, which have sections describing details of the user interface API and for creating Earth Engine apps itself. And if you get stuck, you can always ask questions in one of the support channels that's described in the Getting Help page of our docs. And finally, there's a collection of Medium posts that further describe Earth Engine apps, including how you can embed your app into your own website. And finally, we would like to invite you to send us examples of the Earth Engine apps that you create for your research papers using our Twitter handles shown below. Until then, happy coding!